It does say show. Do I have to? I definitely have not done this. How it should be. So used to remind me. Do you say this one?
You've done 6. Can you do 6, please? Question 6.
Right, so that approximates to a normal. That approximates to 0, 1. You said what?
There's a fellowship going around, make sure you sign your name, okay?
Can you
we've just transformed it back to 0, 1. And you just shifted it. I don't know why we changed it to A. You can't do that. I think it's okay. Yeah, but I think you've got to do the Z bit first to prove that that's on a debit bit. And then you've got to do it. It's just showing that those categories. Certainly not again. How do you get it? You prove that.
You guys done? Question 6, part 1. Alright, and you are given a variable x which normally distributed with parameters this and this. Now if you look, I mean we talked about the normal distribution about 2 weeks ago, you may recall. One of the properties I mentioned in my lectures is the following, that do you remember this? This is one of the properties of the normal distribution I mentioned in the lectures. Do you guys recall this or not? Yeah? Okay, so the CDF of x by definition this is the CDF. Yeah? This is the definition of a CDF. Now what I'm going to do is I'm going to take on both sides, I'm going to subtract mu and divide by sigma. Now this guy, because of this property, this guy has the standard normal distribution M01. Okay. And the notation for the CDF of a standard normal is 5. Alright, it's not difficult, is it, guys? So this is how you will do part 1 of question 6. Is it okay? Yeah. Okay, to do part 2, there's a part 2 for question 6 too. First is asking you to compute the quantile function of a normal variable. Now, this is questions. The quantile function is defined by Q of P. The quantile function of a random variable x is defined by the following. I will talk more about this next week, but I just want you to know that quantile function of a variable, of any variable, it doesn't need to be normal. I mean, of any random variable x is defined by this equation. So Q of P is the value for which this probability is equal to P. Now, if x is a normal variable, then I mean, this is the same as saying that the CDF of x at Q of P is equal to P. Now, if x is a normal variable, right, then this guy we know is equal to phi of Q of P minus mu divided by sigma is P. Okay. Now I'm going to take the inverse function on both sides. If you take the inverse function, then you get this, right? And finally, if you rearrange this, you get Q of P equal to mu plus sigma times phi inverse of P. So this is the quantile function for a normal variable with parameters mu and sigma squared. And this can be done for any distribution. The starting point is always this equation here. This is the starting point for any distribution. But this here we done it for the normal random variable. Okay. Now the question it's also asking you for the IQR. Do you guys remember what IQR is? I talked about this in the class. IQR is the interquartile range. What's the definition? You guys remember the definition of IQR? This is the definition. The third quartile or quantile minus the first quantile or quartile. Okay. Right. Now, from this, if I call this star, and okay. All right. Hence, the IQR. The IQR is the difference between these two, which is sigma you can actually read these values from the normal table, which I showed you a couple of weeks ago. Or was it 2 weeks? Maybe the last week, I can't remember now. But anyway, if you read them, you will get 1.349 times sigma. Alright, so that proves, that completes question 6, okay? Part 3 you can ignore. Any questions on this, guys? Are you okay with this or not? Yes? Alright, can you do question 2, please, now? Question 2. the 5-number summary is these numbers here: the minimum, the first quartile, the median, third quartile, and the maximum. Those are the five numbers. Okay. Yes.
We just found it.
Anyone who hasn't signed it, guys. Can you guys do question 2, please, now? It said the 5-number summary are these numbers here, okay? Thank you. Anybody else who hasn't signed the attendance sheet?
So it's a quarter of the way to six is quarter. No, you find it. So you're gonna find a quarter of the way from.
But there's another formula I gave for the means. Yeah, it's the same. It was the same. Okay, guys. You guys okay? Alright guys, shh. So the 5 number summary is, as I said, first of the 5 numbers is the minimum, which is obviously 29.14. Okay. The second is Q at 0.25, or the first quartile. So your P is 0.25 and your N is 20. So your R is, so use the formula that I gave you in the lectures, right? Which is P times N plus 1. Right, and if you work this out, you get 5.25. So R prime is the integer part of this, which is 5. So Q at 0.25 will be this, okay, using the formula, right? And if you work this out, you get 37. All right, so that's the first quartile or quantile. All right, the next one is the median, our Q.05. I mean, I gave you two different formulas. You can use either this formula or there's another formula I gave you for the median, if you may recall, which is, because n is an even number, if n is an even number, the formula that I gave you is the following. I will write it down if you don't remember. You will probably remember if I. This is the formula I gave you for the median. This applies only to the median when n is an even number. In this case, n is 20, which is an even number. Okay. So this is half of x10 plus x11. Yeah, so you can work that out. You should work this out. It will be 41.186. So that's the median. And the next one is the third quartile, which is this, right? So your P is 0.75, your N is 20, so your R is, which is gonna be this, right? You guys follow me? So R prime will be what? R prime is the integer part, which is 15, right? So Q at 0.75 will be, listen guys, please. It will be this. So again, once again, I'm using the same formula as here. So this you can do. So this is the third quartile, and the final number that we need to find is the maximum, which is again trivial. So the maximum is the largest data point, which is 51.261. All right. Okay, so we got all the five numbers. Okay, you guys okay with this? Now the next thing, part 2 of question 2. So this is question 2, part 2. Is asking you for the sample mean and the sample standard deviation. I'm sure all of you know how to compute the sample mean. The sample mean is simply you add all the numbers. There are 20 data values. You add them and divide by 20, right? And you will get 40.6942. All right, this is the sample mean. And the samples, to find the sample standard deviation, first you need to find the sample variance. Remember, listen, I gave you two formulas for sample variance. There's a biased version and unbiased version. From what I talked about yesterday, unbiased is a better estimator, right, than a biased estimator. So I will use the unbiased version, which has a n-1 in the bottom, right? You divide by n-1, which is see, unbiasedness is a good property of an estimator. So you always want to use the unbiased estimator if you can. Okay, so if you work this out, you will get this is what you get. Okay, and the sample SD is the standard deviation, is simply the square root of this, so it's the square root of this number, which will be .527. All right, guys, are you with me? Okay, right, that's part 2. Part 3. Part 3 is asking you to draw a table. It's a frequency table. I'm sure, I mean, if you did this in A-level S1 or S2, you would have done things like this. So it's basically, you need to have 3 columns. The first column is interval, the second column is a frequency, and the third column is the density column. So so we're going from 25 to 55 in steps in lengths of 5. Okay, so the first interval will be 25 to 30. Okay, and the next one will be from 30 to 35, 35 to 40. Oh, shit. No. What did I do? Okay, here we are. That one. The next one is from 40 to 45, 45 to 50, and the next one is from, or the last one is from 50 to 55. Okay? Then you just count, okay, the frequency is basically the number of data points that fall in each interval. So for the first interval, you should count, there's just one data point. For the second, there are 2. The third, there are 5, 8, 3, and 1. Okay? So the total number of data points is, of course, 20. Now the density column, the density is, all right, you have to divide by 20. 20 is the total number of data points. But you also need to divide by 5. 5 is, I will explain why you need to divide by 5 in a minute. You also need to divide by the length of each interval, which is 5. All right? So it will be 2 divided by 20 times 5. 5 divided by 20 times 5. All right. The reason that you have to divide by the length also is the following. It comes if you go to the next part. Let me show you. You should go to the next part, which is this is question 2, part 4. Okay. Now, what we have done is we have to get this histogram, right? We have plotted the density column versus the interval column. So the histogram is histogram is the plot of the density column, which is this one, versus the interval column. And I'm lazy to do the plotting, so I just plotted it. I just drew it using the computer, or the R. In R, by the way, if you want to draw this in R, all you have to do is just type hist x, where x contains the 20 data values. All right, now let me explain why I have to divide by 20 and 5. The reason for that is because if you add all the areas behind, if you add up all the areas of the bars, right, they must add to what? They must have, you did this in probability 1, guys. What, for any density, the area must be what? Must be 1, right? If you don't divide by 5, the area will not be 5. It will not be 1. Yeah, that's the reason That's exactly why you need to divide by the total number of data points and also the length of each interval. To make sure that the area of this histogram, area behind the histogram is equal to 1, which it must be, because otherwise it cannot be a density. I mean, you must have done this in this probability 1, that any density must sum to 1 or integrate to 1 if it is continuous. Okay? Okay, guys? So that's exactly why we divided by 20 and also 5. Okay? Now, part 4 is asking you for the shape. The shape is approximately symmetric. Yeah, it's slightly skewed, but it's more or less symmetric. So that completes question 2. Is that okay? Unless you have questions. Do you have anything you want to ask? Okay, can you do question 7, please? Now, question 7. Are you guys doing? Okay. So, okay, man. Hello guys. Question 7 should be easy for you, given you've done quiz 3. Yeah, all of you done quiz 3, right? Shh. Can you listen, please? Question 7. You want to find the median, so P is a half. All right. So we need to consider two cases. Let's consider the case n is odd first. If n is odd, then your r is half times n plus 1, yeah, and your r prime is the integer part of this, which is what? What's the integer part of? If n is odd, n plus 1 is even, right? Even divided by 2 is an integer. All right, so this will be n plus 1 divided by 2. Okay, you follow me? Yeah. So q at half will be, if you use the formula, this will be x n plus 1 by 2. R is n plus 1 by 2. R prime is n plus 1 by 2. So it's 0. So this whole thing disappears to 0. Alright, so the answer is x n plus 1 by 2. Right, that's if n is odd. Right, now if n is even, r is n plus 1 by 2. R prime is the integer part. Now if n is even means n plus 1 is the odd number, so odd number divided by 2 is not an integer. So what's the integer part? The integer part will be n over 2. Okay. Okay, so q half will be right, and we can simplify this to get and this can be simplified further to get the following. Alright, so this is the formula for if n is even, right? Okay guys? Okay. If you have time, you can try question 5. So you will not be able to do question 4 because it's outside the syllabus, but I do not have the material, but you can try question 5 if you have time. If you've done question quiz 4, can you please give it to me? If you Thank you. Have a good weekend, man. Thank you. See you. Hello, Rama.
I can't find my name on the register.
Yeah, just sign it at the bottom.
Oh, okay.
Did you do that?
No, I didn't. I didn't know.
You can sign it. Thank you, Ron. Thank you. Bye. Have a good weekend.
Me too.
Yeah. Constantine. Thank you, man. Thank you.
So yeah, you changed it.
Yeah,
Yeah.
I'll change it.
Yeah, because it was confusing.
Yeah, no.
It's basically asking why we would.
I think isn't it 1.5 AQR from
Yeah,
the
yeah.
whisker, so 1.5 AQR.
Yeah, that's what I thought as well. So I mean, in this, I mean, and also that's the way you kind of define the threshold
Yeah,
here. So I mean, the numbers are correct, but
yeah.
the font is different. And this probably, yes, was done automatically now. So probably there's